Joel Stout, you ready? About as ready as you're going to get?
Good morning. My name is Joel Stout. This is my facility, as Jimmy calls it. I would like to thank all of you for being here. This morning we're going to kind of talk a little bit about electrical systems. I did not prepare, even though Bird told me explicitly to prepare. I should have started out with a joke. Charlie said I was the joke. So thank you for that, Charlie. You haven't received your bill yet for your annual, which is the real joke. It's all right. That's all right. So this morning we're going to talk about the electrical system of the Aerostar. And if you have any questions or you want the conversation to go a different way, just ask questions. It's going to be kind of open to any suggestions or anything like that. I think one of the points that I wanted to make was that, you know, everybody has GPSs in their airplanes. Everybody has, or a lot of people have flat panel displays, autopilots, everything like that. And it all relies on a very antiquated system, you know, a battery, alternators, things like circuit breakers. But how many people have actually thought about changing the core systems or upgrading the core systems? You know, newer batteries. You know, how many people, when they put avionics in their airplane, are telling their avionics shops to replace all the circuit breakers? It's a single point of failure that costs $17, and you just put this $20,000 piece of equipment in, and now you've got this old circuit breaker that you can't hardly inspect because you can't get your head up in there, and a mirror, and there's wires, and there's butt connectors on the backs of them, and everything like that. It's just kind of something that we find a lot, and just wanted to kind of make everybody aware that there's more to avionics upgrades and things like that than just the actual avionics that you're installing. One thing that we are testing right now is we put a lithium iron phosphate battery in an airplane. So far we're having great luck with it. It's not certified yet. But one of the advantages is that we have a very high voltage, you know, about 27 volts to about 10% left on a charge. So you maintain a much higher voltage, easier starting, things like that. You save 33 pounds. And with that airplane, we also, you know, rewired everything, things like that, with the, you know, from the master relay the whole way up to the bus bars, and really kind of makes the airplane a lot more reliable. We've done, you know, we have an infrared camera that we will actually check, you know, the temperatures of the cables and stuff, and it's amazing. You get hot spots in the cables from corrosion and things like that. These airplanes are 40 to 50 years old. There's corrosion, there's other issues that you can't normally see. And people who aren't specifically, you know Aerostars may not know these weak points. Does anybody have any questions about anything so far, really? Well, Jimmy, you know, some people would say that, you know, when things get old and kind of don't work so well, you should upgrade them. What's that? What else do you want me to talk about, Ken? Yeah. So we're testing a EarthX 24-volt lithium iron phosphate battery. It weighs 8.9 pounds, as opposed to 43 pounds or 42 pounds on the Concorde or, you know, Gill G247s, and it really brings your CG up about 0.6 of an inch if you have it mounted in the tail. This aircraft is actually mounted right behind a hydraulic reservoir. But yeah, it's the only issue that we're really having with it right now is, first off, we have to figure out how do we tell how much charge is left in the battery. Like I said, a lithium iron phosphate battery will keep the voltage very high till it's pretty much dead. So yes, it has the same amount of, you know, ampere hours basically as the G247, but how do you tell? There's no indication to let you know that you're almost dead. The other thing that we had kind of an issue with is there's very little internal resistance with the battery. So, and this will get me to the next point, but when you're charging it, you have to be very careful that you don't overcharge it. So our startup procedure is a little different. On this particular aircraft, we have the plain power alternators, which will do 55 amps at 1,000 RPM. About 950, it'll do 50 amps. So it'll charge very quickly. And when you start the aircraft up, you turn the alternator on, you have to make sure it's pretty much back at idle, or because of the low internal resistance of the battery, it will charge it very quickly. In fact, our startup procedure for that aircraft is start it up, pull the throttle back, then turn the alternator on, watch the amperage, and it'll go up to about 30, 32 amps at idle, and it'll slowly work its way down to about 13 amps, and then we can start the left engine. If not, we risk, you know, kind of overcharging the battery and issues. So that's kind of a couple of things. You know, what we would like to do is actually come up with a kit and sell a kit to basically upgrade your core electrical system to, you know, maybe not quite the 21st century, but late 20th century at least.
So just to be clear, there's not a certified battery for airplanes yet.
There's not a certified 24 volt battery yet.
Well, there is a 12.
There is a 12 volt battery from EarthX, and they're blue. That the Cessna, we have one around here. I can, if one of the boys, you want to grab that battery, we'll just.
So can you do two 12s and?
You can't, because there's internal circuitry that limits seriesing, putting the batteries in series. So that's one of the issues, is we're trying to come up with a way to measure the state of charge and be able to actually put two batteries in parallel, so that you have basically twice the ampere hours that a 247 would have, but you're still at half the weight. And here's a 12 volt. You could actually pass this around. You can see how light this battery is, and some of the advantages. It's a totally sealed battery. You know, you don't have any, you know, acid or anything that could get onto the paint or anything like that. Well, you know. So lithium, yeah, the lithium iron phosphate batteries are substantially better, but there are still some risks with it. But they are a lot more stable than some of the older batteries, you know, like the LiPo batteries and stuff like that, you know, that would just spontaneously combust. There is, so there's a couple of things, like they do make like bags and special boxes for certain batteries, like in home builds and things like that. But we're still kind of working, you know, with EarthX, you know, to kind of help them and see, you know, if it's a viable, you know, if it's actually going to be a reality to be able to get it certified. But it is certified as a 12 volt, so it shouldn't be. Well, correct, and it's so the 24 volt battery will take 80 amps of charge. Okay, the thing is like everything else, we don't want to push it to the limit. So for our testing, I am limiting the amount of amperage. Okay, it's not something that the battery manufacturer says, hey, 80 amps, it'll take it all day long. But as most of you probably know, the faster you charge a battery, kind of the worse it is for it. So it's kind of my limitation that we're limiting the 30 to 35 amps on startup. And one of the things that we did with that aircraft specifically is, you know, a lot of you probably have the alternator exciter kit, where you have to have the alternators on, you start it up, and the alternator will actually start to work. We wired this so that the field is actually coming right off of the bus. So you turn the alternator switch on,
So
boom,
like 700 feet.
like anything after 83. Yep. So I think some of the later 602s and, like you said, the 700P actually has the field. It's tied directly to the bus, and there's a 10 amp breaker in between, as opposed to coming off of the isolation diode in the back, which you have to have the alternator working to be able to turn the alternator on. You know, basically, or run at really high RPM. So that was one of the things, and so that goes into the alternators that we put on. National Air Parts alternators were the high output alternators, and then they decided to not make them be reliable any longer. And we've been having tons of issues, so we switched to plain power alternators, and have had great luck with those. But there's a couple of idiosyncrasies with the plain power alternators. One of them is that we have to have a constant power source for the field terminal for the regulators, and that's. Oh, he did? Yeah, he was.
What about the weight and balance? 33 pounds. What level on it?
Yeah, well, I mean, so Aerostar has a kit to move the battery from the tail to behind the hydraulic reservoir, which is to combat that. The engine-driven AC helps that issue, and now we could do it by simply replacing a battery. We can move, you know, the CG up about a half inch. I think it's like 0.6 inches. So
Okay.
very, very easy.
Because I know a lot of times, I mean, I fly with weight in my baggage compartment just because it's easy to get 601P.
Yeah.
601P, it's easy to get their weight too far forward. Not too far forward.
Yeah, I haven't heard of that too much. Usually it's FCG issues that are kind of, but I don't have any FCG issues when I'm flying. I'm pretty far forward. A little hard to flare. Well, the one thing, so the FAA kind of says, well, how do you know how long you have? How long, you know, you have fuel gauges, let you know how much fuel you have. You can fill the airplane up and calculate it that you have exactly, you know, 3.5 hours, or the way I fly your airplane, 2 hours of fuel on board. But you have gauges, you have fuel gauges, you have things that in almost every system. Well, but you can deduce the state of charge by the voltage, pretty much, that's coming out of that battery. So a lead acid battery will lose its voltage pretty continuously. Okay, it's like it's a gradual slope down, or you know. Well, there's a lot of variables, Charlie. Yes. But so trying to prove this to the FAA can be a little difficult. They're not 100% logical, you know.
I'll tell you one thing, I have swapped out a couple of golf carts with them. The bigger battery systems, they actually have a battery, I think they call it a battery charge circuitry built into them.
Yes.
And you can actually go in and set like the taper on your charging and you know all those things, and so the charger supplies a certain amount of voltage, and then that system controls to yours, you know, how you set it.
Correct. And golf carts are great in that respect, that you don't have to ask the FAA for permission. So the batteries actually have the circuitry to be able to do this.
Right.
We just have to get it approved in a manner that the FAA is happy with, is basically the issue. They've been using them a lot in experimental aircraft, so to do it is kind of more just a matter of time more than anything else. Everything is there, like you said, for your golf cart. They've had these battery packs. You save hundreds of pounds. It goes faster. It's great. And they have circuitry in there that'll tell you the state of charge, how to charge it, things like that. But trying to get the FAA to kind of agree to all that is kind of the trouble that we're having now. But yes. You mean endurance as far as? Okay, so let's say we have a double alternator failure. Okay, a standard G247, which is a Gill battery or a Concorde, has, I think it's roughly 16.7 ampere hours. So that's 16.7 amps, and it'll last 1 hour. Basically, is how they come up with that number. The lithium iron phosphate battery is about 15.3, 15.4, so it's a little bit less. But the thing is, let's say you're at 25,000 feet. Okay, worst case scenario, to descend, maybe do an approach. I mean, if you have a double alternator failure, you're going to probably declare an emergency if you have to shoot an approach. So they're going to get priority handling. You're probably going to be on the ground in 25 minutes. Figuring 1,000 feet a minute, probably a little bit better. And so that would give you roughly 30 amps. How many people are running 30 amps? If you have a double alternator failure, first thing you're probably going to start descending. Get everything kind of, set up for landing, and then you're going to start shedding the load. And so that's one of the things that we really want to try to be able to put 2 of these batteries in parallel with each other so that we can almost double our capability and still be at half the weight. But there's, like Joel kind of pointed out, there's a lot of circuitry in the battery to help it charge, help it, give you warning lights, things like that, to know what the condition of the battery is, that kind of limits paralleling them. So you kind of have to design it that way out of the box. So that's kind of one of the issues that we're running with EarthX.
The other benefit is battery life.
Well, the other benefit, and you don't need a trickle charger. So I think a standard lead acid battery loses roughly 1 or 2% per week, almost, of the state of charge. A lithium iron phosphate battery will lose 0.1% in a month. So you can literally let your aircraft sit for a year without, I wouldn't recommend that, but without charging or a trickle charger, and the battery will still be ready to start the engine.
Most of them have a 10-year warranty or something like that.
Yeah, yep, very good warranties, stuff like that. There's a lot of benefits, and they are a little bit more expensive, but if they last 10 years, I think Lloyd Martin's the only person I know that had a battery last 10 years that was a lead acid. Kind of shocked when he pulled that out. It's like, oh, you're a deal. Correct, and so along with new electronics and everything like that, they're very susceptible to voltage changes. And sometimes you will actually start to lose voltage, and you won't necessarily pick up on it right away, because it won't be like something just quitting, but your magnetometer or AHARS might start just giving wacky readings, which can be very unsafe. So we're kind of arguing the fact that, hey, we can have, everything can work 100% for 90% as long, as opposed to stuff slowly fading away. Even though the ampere hours are a little bit higher on the lead acid battery. But the thing that we're arguing is that if you have a double alternator failure, you're not going to be like, oh, well, let's just continue the trip. We're good to go. Joel said everything's fine. We're arguing the fact that you're basically going to declare an emergency and land. So.
You got a plain power alternator here?
Yes. I have one of each. If you. Hey. I keep forgetting. I have helpers. Do you want us to pass them out?
If you will,
The
start
one.
with the camera first.
Oh, okay. So this is the plain power. I don't want that yet. This is plain power alternator. And like I said, it'll do 55 amps at 1,000 RPM. It'll do 35 amps at idle, 700, 750 RPM. And then this is actually a 100 amp alternator. So it'll, it's hitting 70 amps at 1,200 RPM, something like that. I mean, it's very powerful, like the National Air Parts. One of the benefits with this system, and one of the things that we do here is we try to make every system more simple. How can we make it simple? How can we reduce the number of connections to increase the reliability? The nice thing about the plain power is the regulators are solid state, but they also include the alternator fail switch and the overvoltage protection. So we have to take out the overvoltage relays, which are 50, 60-year-old technology. What's that? Yeah. And we can get rid of the alternator fail switch, which is more connections, more things to fail. So the only thing that you have to do to install one of these, other than a little bit of rewiring, the plug and everything, is just to make sure that you have a power source for the field to the regulator. So a little bit extra install initially, but that's kind of our preferred method anyway when we change things. Yes, Doc? I think you can put them on one at a time, but I don't think it parallels as well as it should. It's kind of like putting a National Air Parts alternator on with a Prestolite or a Hartzell. You could do it, but you have one point where they're going to be paralleled. Because at idle, the National Air Parts is going to be putting out a lot of, amperage. And so, it's going to hold 95% of the load. And then as you bring it up, it'll start to balance out. And we've had a lot of issues with regulators and alternators lately that we kind of prefer to just replace both regulators and both alternators. You can also get the plain power regulators and replace the Lamar ones with them. But again, these alternators are far superior of what the Prestolites or the Hartzels have been. Well, that we haven't quite worked out yet. Same belt. Yep. One thing that we've done that we've kind of started doing is, at one point they were making alternator belts a certain thickness. Then they decided, without telling many people, that they're going to make them a little thicker. So they ride a little higher on the ring gear, and makes it very tight. Like you have really no adjustment. You darn near break the belt trying to get it on. So one thing that we have found that helps is actually if you buy the engine-driven AC pulley for the idler pulley, it's actually smaller and actually gives us some adjustment. They're $284 from Aerostar. So we found that that's actually very nice and helps the bearings and stuff. Sometimes they're so tight that you just know it's putting a lot of side load on it. Well, that's just the idler is a smaller, so it gives us just a little bit more room to adjust it, and we can get a little less belt tension sometimes. Well, like anything else in aviation, they are today. So they've been around for a while. Tomorrow, maybe. We'll call. Yeah, they're owned by Hartzell, so that's. You wanna? Yeah. But they are a bigger company, I think, than National Air Parts. The National Air Parts alternator. This was the heavy-duty alternator. That was preferred in the past. Last 5 years or so, we've had nothing but issues with the reliability. In fact, I had one where we had the APU on an airplane, and all of a sudden we pulled the one cowling off, and my son and I are standing there, and I'm like, do you smell something burning? And he's like, yeah. And I'm like it almost seemed like maybe like somebody turned on a prop de-ice or something, you know, and the brushes were getting hot. And I looked down, there's smoke coming out. So we popped the bottom cowl, and the National Air Parts alternator, you couldn't even touch it. It was so hot, something that shorted. Brand new, had like 2 hours on it. So at that point we decided probably best to pull both of them. And the funny thing is we had an issue when we pulled the one. I ran the airplane, I forget why, to test engine instrument or something. And I was back at the regulator, and I went to touch the regulator on the other side, and I couldn't even touch it. It was so hot. I was like, "Ooh, this isn't this isn't a real safe situation," you know. And so there was something going on with the National Air Parts alternators. So we put the plane powers on, and it's been absolutely fantastic since. Perfectly. What's that? No. The customer decided that he didn't want to take that chance. So, you know, in-flight fire in the back on a 176 panel, you know, probably not a real safe situation. So we can pass this around too if you want. This is one that we had pulled off. It had engine-driven AC, but the main bracket was broken. It was still working, but the bearings were a little shot, and found that most likely cause of the bearings being shot was because the pulleys weren't aligned with the ring gear. But I don't know if you guys want to. We could even. I don't know if you want to do like a little show and tell, Ken. And, I mean, we could just set stuff up around the hangar too, and at lunch or whatever. So that's kind of the basis of what we're doing with the electrical system. Any questions? Anything else?
Let's talk about the electrical system associated with the fuel indication.
Okay.
Fuel.
So what do you?
Well, just the places to look for when your fuel gauges are going crazy.
Okay. So common problem with our aging fleet are the fuel gauges. I don't know how many of you have had issues with them. I think probably everybody. Yes, Bruce, we know. Put your hand down. Bruce has been giving us a little bit of a little issue. One of the things with the aging fuel system is a lot of times you'll get a pegged down or pegged up indication. Pegged down, you know, you've got an open. Pegged up, you've got a short of some sort. You're getting too high of voltage. Fuel gauges on an Aerostar are basically voltmeters. Simple as that. The way a capacitance system works is you send roughly a 5-volt signal out to the wing, and whatever the voltage return is back, it increases with the fuel level, and the conditioner box basically converts that to a voltage that the gauges will read. And that voltage, I think, is between 1.23 volts when it's empty to about 1.4 volts when it's full, somewhere around there. So it's a very small voltage window from empty to full. And one of the issues, and along with the rest of the electrical system, is corrosion from age. With the fuel system, because of the low voltage and because of how sensitive it has to be from empty to full, because fuel isn't a real good conductor, is a corrosion issue. We've been finding a lot of what we do is if we have a peg down, we'll let's say a left wing, we'll pull the panel, we'll pull the transducer or the transmitter out, and we replace the cannon plug on the end. We do everything not to replace the cannon plug in the wing. It's not the most fun job to do, and they're kind of expensive because they have glass blown, insulators in them, and so we'll clean that. I think Ken, you had replaced the cannon plug in the back on your conditioner box. which we stock all the pins, all the connectors for the whole thing. Have had a lot of corrosion in the fuselage sending units. Normally, if you clean them, though, it's kind of fixes it, and then you give it back to the customer, and an hour later, it fails again, as in Bruce's case, where I have pictures of it all working, and then he gets it. Anything else? I mean, corrosion is a killer in electronics.
There's a company in Wichita, Kansas, I'll look them up, that repairs the transducers.
Yeah. We keep the Canon plugs in stock, and we've had pretty good luck replacing them ourselves. You know, another issue is that you'll go to calibrate the fuel gauges, you'll get 0, you fill it up, and you get 40 gallons. You know, and you don't have the adjustment to be able to bring the fuel quantity up where it should be, and that's again usually a corrosion issue. There's no moving parts to the transducer. Yeah. Yeah, we do ours in house for the.
And all they do is replace the Canon plug?
Yeah. Yeah, like I said, there's really nothing, I mean, unless you damage it somehow. You know, pulling it out, throwing it across the shop floor because you're upset or not real happy with something, you know, Justin. Yeah, so and then we have like special files that we use to get into the pins and stuff. You gotta be careful. I think those Canon plugs in the wing are about $650. Well, and that's the cheap part. The labor is sometimes worse than that. And then you risk leaks and stuff like that. That's another thing, like if you've ever seen, you know, fuel leaking around your strut door or something like that. I don't know how many people have seen that. I think, Bruce, you had that issue at one point, didn't you? Where one of the, you know, you're doing a pre-flight and you see a little bit of fuel coming out of the strut door. Again, with that fuel leak that Ken showed everybody earlier, I wouldn't fly the airplane because what it's doing is it's actually running down the spar, sitting in the back of the engine compartment, which is not a real nice place for it to be. I mean, that's, you know, you have the drains on the bottom that supposedly drain them out, but you still have all the fuel on the spar and everything like that, and it's running down in the gear well. So, but that's a lot of times the culprit is that Canon plug is leaking a little bit. Anything else with the fuel system?
We talked about cleaning the contacts on even there's 4 connectors involved.
Well, you have one at the gauge, one at the conditioner box, one at the wing,
These can be simply
and then,
contact cleaning.
well, contact cleaner, we also have a set of like little files that go over top of the pin, and it's got abrasion like on the inside of the tube, and we can sit there and just kind of clean it pretty well. And the nice thing is we don't put any side load on the pins. We don't loosen anything up. You know, like if you take sandpaper or something, you know, you kind of wedge it in there, and so the right tool definitely helps, Jimmy, wherever you're at. Just that, you know. Actually, you do. That is the one tool I noticed you had in your toolbox. That mess of a toolbox. I think they're in the 3rd drawer down, center section. You get her from Snap-on. I'm not a Snap-on rep or anything, but we're good friends, me and the Snap-on guy. But yeah, I mean, I would, you know, anything else? I mean, that's basically, it's a very simple system. It's very easy. It's just problematic because it's old. It's getting old. It's a very reliable system, very good. You just have to maintain it like anything else. Any other questions? Electrical, anything? Walter? Yeah. Another thing that we found also is that the shielding on the wires that go out to the connector. It's a 2-conductor shielded wire, but they actually use the shield. It's not just a ground. It's not like a local ground like for a microphone jack or something like that. It's a conductor. And we found where the little solder joints on top of the connector, where the wire strain relief was at, and you clamp the wires together, would actually kind of break that loose. And so you would go back, you would just move a wire just a little bit, and it would start working, or it would fail, and it was actually that solder joint. So we've done quite a few of those. You know, you have to do it right. We pull the pin out and put a new solder sleeve on and put a new pin on. But this is stuff that if you know, like Ken was saying, you know, this is why you take it to somebody who knows Aerostars. You know, you don't want them just replacing conditioner boxes and gauges and saying, oh, your gauges are bad, you know. And it ends up costing you a lot of money when it turned out to be $1 solder sleeve. But if you don't know Aerostars, you don't know the system very well, you don't know of these little idiosyncrasies. Well, that's what I was saying. Like, I don't think there's really an issue with the setting units. It's the fact that the system's 40 years old. You know, I don't work as well as I did 20 years ago. You know, Ken doesn't. So, you know, it's all with it's the maintenance of it. It's why you replace the circuit breakers that are 40, 50 years old when you do an avionics upgrade. You know, these things, everybody wants to complain about how unreliable they are, but they didn't complain they didn't praise it the first 35 years it worked perfect. You know, but now everything's getting a little older. That's why, you know, maintenance on these airplanes are even more critical. And who's been doing the maintenance and things like that. And so. Yeah. Yeah. Well, so it depends on, obviously, the avionics that you have in your aircraft. And yeah, new or old, and you know, are you running boost pumps? Are you, you know, I don't know why you turn off the fan. I mean, that to me is kind of an emergency. You got to have that on. You don't want to overheat. But I think like a standard draw is probably, you know, just turning the master on is, you know, a couple amps. Each boost pump is going to be a few amps. What else are you going to want to run? You know, a GPS. Well, you're going to have a glass, you know, well, he doesn't have a glass panel on his, but not yet. Next week. But yeah, I mean, so one of the drawbacks to the glass panels is that it is all electric, so you will constantly use that electricity, whereas if you had, you know, an air-driven gyro, if you had a double alternator failure, you know, but how many people have had vacuum pump failures? How many people have had dual alternator failures? Walter, Charlie? Double alternator failures. So 5 or 6 people. It's a fair amount. So with that being said, basically you lost both alternators because of a small bolt or a terminal that was so inconsequential to what everybody thinks is important, which is kind of what I was, you know, with the circuit breakers and the master relays. And, you know, master relay is $140, you know. Why are we, why are we not replacing them more often? Things like that. It's kind of an important piece, in my opinion. But yeah. So to answer your question, Bob, with a transponder on and a G500 system, which is in a lot of airplanes now, you're probably around 15 amps, I would say, right, Ken? Somewhere around 20. It depends on what you have. When you transmit, you're going to be drawing more amps, things like that. So that's the thing. It depends on, like, I think Tom's Aerostar runs it like, with everything on, it's running at like 16 amps. So if you start shedding a little bit, but new avionics is one of the benefits of new avionics is generally they're going to require less amperage, except for with the case of like a G500, and then you have the standby instrument, which is usually electric also, so you've got another amp there. So. Sure. No. No. If you would load it up with, and you had one that was putting out 50 amps and one that was putting out 5 amps, yes, that's an issue. Down low, I don't know. I'm sure Alan and Don have probably seen the same thing. It's difficult to get them lined up down. When you're pulling 1 or 2 amps, one on there, they're generally going to be 1 or 2 amps different maybe. Keep in mind that, an ammeter is, again, very old technology. It's literally, a difference in voltage from one side of the shunt to the other side of the shunt. And there's a lot of variables that could cause, an error in reading, corrosion. Again, corrosion will cause an ammeter not to read correctly. The ammeter itself could have, an issue if if you have one ammeter, obviously that's not the issue. But so even though you're indicating maybe a little bit of a difference, it may not actually be the alternators. But again, down low, a couple amp difference is not anything to be worried about. Yeah. Yeah. I mean, that's, and that, yeah, bring the amperage up, start turning stuff on, and then seeing how balanced they are. Yeah, if it's only 2, I wouldn't worry about it. Yeah. I mean, the National Air Parts? Yeah. 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 Yeah, sometimes you have to wake them up, It's kind of like using the autopilot. You gotta wake up. Yeah. Yeah. Yeah, and I've got a customer that has kind of a similar situation. One alternator will be carrying more of the load, and then you'll be flying along, and it'll just kind of equal out, and then it'll switch to the other side, and it kind of wanders back and forth. One of the analogies that I use with people between the National Air Parts alternator and the Pressolite is, National Air Parts alternator is kind of like a big block Chevy. It'll put out the power at low RPM, but it kind of puts out the same amount of power. The Prestolites is like a Ferrari. Low RPM, there's nothing, but as you rev that thing up, she starts putting out some power, and that's one of the issues that we have with kind of getting everything perfectly balanced. The main thing is that, you know, both alternators are carrying somewhat of a load, and they will sometimes wander like you're having, you know. With the plain power though, so far, they've been, you know, rock solid. You know, with plain power alternators, plain power regulators, very consistent. Yeah, and you know, realistically with the alternators, the regulators, everything, you know, it's probably about a $5,000, $5,200 upgrade, because you have to do some rewiring and things like that. And the mounts, you can't order the mounts that they tell you to because they're wrong, and Jimmy knows the part number for those. That's the time to do it. Yeah. Yeah. What do you mean a full blown? Well, so one thing that we try to do is, you know, it's hard to tell somebody, hey, fix this, even though it's not broken. But what we'll do is we'll have, like, let's say I had a customer and his master relay was a little rusted and corroded, okay, because it was original. So what we did was we pulled the master relay out, put a new one in. I rewire everything, new battery cables, new APU plug. We painted the battery box, basically overhauled that section, okay, to get rid of that weak point. Replaced the cable going down. You know, the battery cable really goes to the back, basically where your aux hydraulic is. So it's actually a pretty easy cable to replace. You know, going through the pressure bulkhead and everything, that can be kind of intrusive. But we'll do that stuff, and by doing it all at once, we're adding a few hours of labor, but not a lot. And when you pull the tail cone off and you look and all the wires are not corroded and everything's nice and tidy, that's one less failure point, or should be one less failure point for quite a long time, which helps in, you know, just everything. You know, the cost of if you have a master relay go bad, or you know, let's say somebody, you know, you go to another airport and, you know, the battery is pretty much dead, you know, what's that mechanic going to do to get you back flying? Is it going to cost you $5,000 in labor because the guy doesn't know what he's doing? Will he pick up the phone and call you, you know, call the mechanic, something like that? You know, who knows? So we tried to slowly rebuild these airplanes, kind of like one thing will kind of, you know, spark overhauling that part of the system. But to sit there and kind of replace everything that should be replaced because it's used, I don't think we have the time, and most customers don't have the money to be spending hundreds of thousands of dollars, you know what I mean, at one shot. So we do try to be a little proactive and kind of overhaul a certain portion of what we're doing. And, you know, let's say we've got a circuit breaker to be replaced. If we've got to pull that whole row of circuit breakers or the bus bar loose so we can get that circuit breaker out, we replace all the circuit breakers. We do an engine monitor install. We replace a lot of the circuit breakers. We're replacing alternator breakers. I've found probably, you know, 30% of the alternator breakers cracked. But again, you can't see them. You can't get a mirror up in there and see the front side of them. It's darn near impossible. So when everything's out, that's the time to do it. Nobody wants to spend money on labor. They would I think, much rather spend the money on new parts. So we try to minimize that labor. Oh.
Let's take a break.
Sorry, Don.
Oh, the one thing I was looking for at some point that you want to correct releases on, is that mandatory cycle time on alternators and starters per fleet.
There are. There are suggested replacements for pretty much everything. But nobody wants to replace a controller every 500 hours or a wastegate every 500 hours like the manual says to do. So that's why you run into certain problems, and you have to understand there's a balance between, do we spend money that we don't think we necessarily need to spend, or do we wait till it breaks and then complain about it? There's kind of a...
Can you get home with the break or not?
So most things, like let's take a wastegate for example, it's not just going to quit on you generally. It's not going to break a shaft unless it's a Nisley, just randomly. It's going to start sticking. It's going to give you indications. But you have to be proactive when it does give you a sign to fix it. And I think there's a lot of people that don't even do that. I had a customer who said his starter wouldn't engage right. Okay, so I sent him a starter. Well, it came in here for annual and it still had a starter in the back. And he's like, oh, can you replace that? It's been getting worse. Well, at what point was he going to wait until he was stuck at an airport? And he knew it. It's the same thing with a fuel pump. You hear something weird with the fuel pump, and oh, that sounds kind of rough. It'll be all right. Jimmy Mullen method, it'll be all right. You know, you got to listen to the airplane too. And I think a lot of the systems will give you indications of issues.
Maybe
You know.
for non-mechanically inclined pilots, a tip sheet on those hours and what to look or listen for on intended failures.
Well,
Might not be a bad thing to publish.
and it's right in the manual. It's right in the maintenance manual. But to tell somebody to replace their stuff, I don't think is on a certain time is not the correct method, because you have calendar time that can also cause issues, and you can have different operators operating the aircraft differently. But maybe coming up with a way that an owner can identify a problem beforehand, or be very vocal with the mechanic. Like I don't always answer the phone, but if you have a problem, I try to help everybody through it. Certain people have, the first thing is if you have a problem with your airplane, call me, leave a message, whatever you have to do, and we'll try to help you. If you're stuck somewhere and you have another mechanic, have the mechanic call one of us, either Ken or I or Don or Alan or Jim Christie out at Aerostar. We all have probably above average knowledge of Aerostars. So call us, let us know if there's an issue. If something is a little strange, we can at least talk through it. And I think that's probably a better method to go about replacing things, is when you see a change in your, whether it's a cylinder head temp or the noise of a fuel valve, mention it to a mechanic or a fellow pilot or somebody to identify the problem before it becomes a real issue. I think is probably more important than giving an arbitrary number that you can, I put a brand new controller on an Aerostar, and 3 hours later it started surging on takeoff. Well, we replaced a controller. Are we going to replace a controller every 3 hours? No. So a time and a calendar time are kind of, I don't think really a good way of determining when something needs to be replaced. I think identifying a problem, knowing your aircraft, knowing the trends, and what it should be doing is a more important and a better way to determine when things need to be